Okay, I just want to provide a short video key of the energy forms and changes simulations. Put your name in. When you open this link, it'll open up in another tab. So we'll get back to that in a second. Then we have that simulation. We're going to go to so in this simulation, you'll be able to see several forms of energy and changes transfer that occur between them. We work with a system. We can manipulate energy input, observe the process, electrical energy generation, and manipulate input. To kind of play around with energy in various ways. We're going to start off with the Energy Systems tab. We'll do almost all of our work here. We'll experiment with the different materials, input, output, combinations. But then we're going to go through kind of the set list. So here we're going to go through. We're going to go in the Systems link. And so the first question says, which energy sources of input could cause a turbine wooden wheel to spin and generate electrical energy? So we have our wooden wheel. If we give the bike rider the speed, we can see that, and we want to make sure the energy symbols are on. We can see that, in fact, the bike rider does turn the wheel. If we change it to the faucet, turn the faucet on, we can see that the faucet does change the wheel or turn the wheel. Change it to the sun. And regardless if we have lots of clouds or little clouds, doesn't matter. That is not going to turn the wheel or change it into mechanical energy. However, if we had set steam underneath it and we apply thermal energy to the water, the energy becomes steam, which becomes mechanical energy and turns the wheel. So what we saw was that the bike, the water, and the steam have the ability to turn the wooden wheel. Okay, and then it says which energy sources cause the solar panels to generate electrical energy. So we can go ahead and reset here, change it to our solar panel. With our bike, okay, how much they pedal, there's no connection to the solar panel. We can try water. Pour water, there's no connection to the solar panel. Put out the sun. Now we see that the solar panel is changing the energy from radiant or light into electrical. So the solar panel works with the sun. And with the steam, we see no change whatsoever. So the only one that will have an impact on the solar panel is the light, the sun. Okay, which energy output objects work with the turbine? So again, we go ahead, we switch to the turbine. We go ahead and put it on something that works it. Let's put the water here. Okay, so we see that the turbine does have the ability to change the mechanical energy to electrical energy, which changes the thermal energy, so that does work. Okay, we change that to electrical energy to a bulb. Okay, we get some thermal energy. We also get radiant energy of light. For a fluorescent bulb, okay, we also get the radiant of light. And then if we have a pinwheel, the electrical energy can start to turn the fan. So we can see that all the output devices work with the... Oh, I can't check all that one. Let's change that one. I will change this one, but it should be all of them. Irritating. Which energy outputs work with the solar panels? So if I go to the solar panels, set to the sun, so it collects solar energy. Okay, we see that the fan does work. We can see that the fluorescent light bulb does work. The standard incandescent light bulb works. And it does change electrical energy, the thermal energy, which will in turn heat the water. So they should all work. I will change this setting on the format so they would all work. Actually, I'm going to do it right now. Sorry, you have to see this. There we go. There we go. All right. Go ahead next. It says, what happens to the amount of electrical energy generated when the faucet's on high versus the faucet on low? Clouds versus no clouds, low heat, high heat. Girls pedals slowly, girls pedals quickly. So again, We go ahead and change it to, let's say, this setting, and change it to the turbine. That's what they work with. We can see that when they pedal fast, okay, they change chemical energy into mechanical energy, mechanical into electrical. We see it's happening pretty rapidly. If I change how fast she's pedaling, then we can see that it is happening slower. And eventually she will run out of energy when she runs out of that. All right, the faucet on high. I see I have a lot of electrical energy. Turn the faucet on very low. Very little energy. Okay, I'm going to need the solar panel for this. On the solar panel for no clouds. We can just put the light too. Let it light up. Okay, we see we get energy of heat, which changes to light. We'll see the light glow. If I create a lot of clouds, we see the solar energy can't get through. I don't get as much energy. The light bulb will get less and decrease. And finally, the girl pedal. I did the girl pedal faucet on the kettle. Okay, we changed to the kettle. Low heat. There's actually no. Well, we have to turn the turbine. Low heat. There's no movement. High heat is when we actually start to get the thermal energy moving. Get the mechanical energy, which turns the wheel. So for all of these, what we see is the faucet's on high, we get a lot. When it's on low, we get a little. When there are no clouds, we get a lot of energy. When there are a lot of clouds, we get very little energy. When there's low heat on the kettle, we got very little. When there's high heat on the kettle, we got a lot. When the girl pedals slowly, we get a little. When the girl pedals quickly, we got a lot. Okay. Okay, we're going to set up the system with the water. With the water and the generator, we're going to get this heat up. And we're going to see how the changes work. So let's go ahead and change water. All right, so we can see. So right now we have no energy going through. If I turn this on, I get the mechanical energy of the waterfall. Okay, it turns the turbine, which is also mechanical energy. That changes into electrical energy as it turns in the generator. That electrical energy changes into thermal energy. It heats up this heating coil. The heating coil heats up the water, which also changes that to thermal energy. And the thermal energy escapes. So that's kind of the process that we see. So what we're seeing is what system energy for the moving water of the faucet turns the turbine. That would be the kinetic energy. It's mechanical energy as the water falls. The kinetic energy of the spinning turbine generates what? Well, as it spins in the generator, it creates electrical energy. The electrical energy is then changed into thermal energy, which is what heated the water. So the first one, it makes the pump move, which is kinetic. Then it changes to the generator to electrical, which then changes to thermal, which heats the water. Okay, now we're going to solar. We use a solar panel and the incandescent light bulb, so let's go ahead and reset. Turn on our symbols. We'll go on the solar, and we'll go on the light bulb. It's asking, in this system, what kind of energy from the sunlight is causing the solar panels to create electrical energy? And then the electrical energy turned into light energy and something else. So here's what we're going to look at. So as the solar energy hits the solar panel, then it changes it into electrical energy. Electrical energy runs up, goes across the bulb. That bulb creates light, radiant energy. We also see thermal energy being given off every once in a while. Now, since we're not using that thermal energy, that is waste energy. So we have solar or radiant light energy into electrical energy, which turns into thermal energy and also light energy again. And since we're not using the light energy, that is waste energy. So in this system, light or radiant energy is changed into electrical energy. It's also changed into electrical energy, which changes the light bulb on, which is the light energy or radiant, but then also thermal energy, which is the waste energy. We're not using it. Okay, and finally, we're going to change the kettle and turn on the kettle and the fan. So the kettle, turbine, and fan. You go ahead and kick this on a little bit. And so we see that thermal energy is changing to mechanical energy of the steam. Mechanical energy of the steam turns the turbine. As the turbine turns in the generator, it creates electrical energy. The electrical energy hits the fan, which becomes mechanical energy. And because it's a spinning motor, I'm going to keep this on high, we should get an occasional, every once in a while, we should get an E, a red E flying off that fan as the energy is, thermal energy is produced. We may not get one, maybe it's, yeah, there you go. So that was waste energy. As the fan is rotating, it's going to lose some of that energy as thermal energy. Okay, so in this system, thermal energy from the flames of the fire transfer thermal energy to the kettle, causes liquid to steam. Thermal energy of the steam spins a turbine, which is mechanical energy. Okay, then that mechanical energy in the generator creates electrical energy, which turns the fan. But every once in a while, we see a red E come from the fan. That represents the thermal energy that's being wasted as the fan is turning. We're not using that energy, so we call that waste energy. And the energy we're not using is waste energy. And as you see this process go on, every once in a while, we get a red E off of the fan, which is thermal energy. We're not using it for thermal energy, so it's waste energy. Okay, we can't lose it, but we can and do change it off. And we'll wait till we get one red E, and then I'll go ahead and stop this. Come on. There we go. So that would be waste energy right there. All right. So make sure you submit when you are done, and then that's your homework for today. Feel free to play around. This is really interesting to watch how the various energies changes. But for the homework, all you have to do is the Google form. Hope you had a good day.